We did not discover 3i Atlas because we control the universe. We discovered it because, in that brief moment, the universe allowed us to see. An interstellar object appeared only once. It left behind data, but not answers. So when observation ends where certainty should begin, where does the real limit actually lie? In 3i Atlas itself, or in the way we observe it? 3i Atlas did not pass unnoticed. It was seen by many eyes, on Earth and far beyond it. Each instrument capturing its light, its motion, its brief presence with precision and intent. The measurements were real, repeated, and consistent. There was never any doubt that the data itself existed. And yet, as more observations came in, something unexpected happened. Understanding did not grow with them. Not because scientists lacked information, but because each piece of data arrived from a different angle, carrying only a fragment of the story. The fragments refused to settle into a single, coherent picture. One set of observations tracked how its brightness changed over time. Another extracted spectral fingerprints from gas and dust. Others mapped its visible structure and calculated its trajectory through space. Every method revealed something, but none revealed the object itself. Everything we knew came indirectly, filtered through light, distance, and models. Modern astronomy is built to handle this kind of uncertainty. When questions remain, the solution is usually simple. Observe again. Then observe again. Patterns emerge. Errors shrink. Confidence grows. But 3i Atlas offered no second chance. Its closest approach on December 19th happened once, within a narrow window of geometry and time. And then it was gone forever. No return. No revision. No opportunity to correct what could not be measured the first time. In the quiet after the flyby, science was forced to confront an uncomfortable realization. It had not failed to look hard enough. It had simply reached the farthest point observation could go. When data reaches its ceiling, but understanding does not rise with it, is that a failure of science, or the most honest limit it can admit? Every observation of 3i Atlas was made from a distance. There was no approach, no physical contact, no direct interaction of any kind. We never measured the object itself. We measured what escaped from it. Light that reflected off its surface. Gas and dust drifting away into space. Radiation shaped by forces we could not touch. What we saw was never the core. It was the coma surrounding it, the tail stretching behind it, the glow produced when particles met sunlight or solar wind. These were not windows into the interior, but traces left behind as the object moved on, like footprints in sand. They hinted at motion, not intention or structure. The vast distance mattered more than it seemed. Hundreds of millions of kilometers separated the object from every instrument trying to understand it. At that scale, no measurement stands alone. Every number depends on a model. Every conclusion rests on assumptions about temperature, density, composition, geometry, and viewing angle. Change one assumption slightly, and the story changes with it. This is where interpretation becomes fragile. The data itself remains precise. The photons arrive where and when they should. The signals are recorded faithfully, but meaning does not travel as cleanly as light. It has to be reconstructed, inferred, and sometimes guessed, using frameworks built from objects much closer and much better known. That is why distance turns data into shadows. Not because the measurements are wrong, but because they are incomplete by nature. The farther away the source, the more disciplined interpretation must become. The margin between explanation and overreach grows thinner with every kilometer. 3. iAtlas forced that margin into view. It reminded us that data can be accurate while understanding remains uncertain, that the farther we look, the more reliable the numbers become, and the more delicate their meaning grows. If all of our knowledge comes from light stretched, it's filtered and altered by distance. Where does measurement end and interpretation quietly begin? Modern telescopes are powerful in ways past generations could only imagine. They can detect faint light across vast distances, split it into precise spectra, and track motion with extraordinary accuracy. But that power has boundaries. It works best in familiar territory, where the rules have been tested again and again. Most of our physical models were built close to home. They were refined using comets bound to the sun, asteroids shaped by the inner solar system, and planets whose behavior repeats on predictable timescales. These objects taught us how to interpret light, dust, gas, and motion. They form the foundation of what modern instruments are designed to recognize. An interstellar object like 3I Atlas does not belong to that foundation. It enters from outside the historical dataset, carrying conditions we have not sampled directly before. When its signals fail to align perfectly with expectation, science has no switch to force agreement. There is no setting that makes unfamiliar data suddenly behave. The only option is to adjust the model and accept that certainty may not follow. The observations collected in December added depth rather than closure. Multiple wavelengths revealed different aspects of the same object, each consistent on its own terms, yet none capable of erasing the central ambiguity. More data arrived, but the core question remained untouched. What we lacked was not sensitivity, but access. As instruments become more refined, this limitation becomes harder to ignore. Precision increases, noise decreases, and yet the realization grows sharper that some properties remain fundamentally out of reach, not because the technology failed, but because the method itself depends on distance and inference. This is the quiet boundary modern astronomy keeps encountering. The tools are not weak, they are simply indirect. They can measure what arrives, not what stays behind. They can record effects, not causes. In the case of 3I Atlas, the instruments did exactly what they were built to do, and in doing so, revealed what they were never meant to measure. If even our most advanced tools can only reveal fragments of the story, are we moving closer to the truth, or merely becoming more efficient at mapping our own limitations? Some of the features observed in 3I Atlas did not match what astronomers expect from a typical comet. Certain behaviors appeared unusual. Certain patterns resisted easy classification. But difference alone is not evidence of anything unnatural. It is simply a signal that the object does not fit comfortably within familiar categories. What followed was not confusion, but divergence. Multiple models stepped forward, each capable of explaining the same observations from a different angle. One framework emphasized composition, another focused on geometry and viewing perspective. Others leaned on thermal behavior or dust dynamics. Each explanation worked. None of them won. This is where certainty began to dissolve. No single hypothesis proved strong enough to eliminate the others. Every proposed answer left room for alternatives. Every solution carried assumptions that could not be independently verified. The data allowed several stories to coexist without declaring which one was true. For science, this is an uncomfortable place to stand. The discipline is built to converge, to narrow possibilities, to move steadily toward a conclusion. When that convergence refuses to happen, the instinct is to push harder. But pressure does not create clarity when the information itself sets the limits. This kind of ambiguity is not a flaw. It is the normal state of frontier science. At the edge of knowledge, uncertainty is not a temporary inconvenience. It is the environment. 3. Atlas did not violate physical laws. It simply exposed how dependent explanation is on the frameworks we bring with us. The object remained consistent with physics, even as our interpretations struggled to settle. What failed was not the data, and not the laws that govern it, but the expectation that every observation must collapse into a single, satisfying answer. When the same data supports multiple explanations of equal weight, should science choose the most elegant story, or accept that choosing nothing at all may be the most honest response? The history of science is filled with confident conclusions that did not survive time. Early certainty has often proven more fragile than early doubt. Patterns, once believed to be definitive, were later revised, refined, or quietly abandoned as new data arrived. With 3I Atlas, the temptation to interpret aggressively was especially strong. The object was rare. Its trajectory would not repeat. There would be no second encounter to correct first impressions. When something appears once and then disappears forever, the pressure to extract meaning quickly becomes intense. But science does not run on instinct. It operates on probability, consistency, and the ability to test ideas against reality. Feelings of significance do not strengthen a hypothesis. Neither does rarity. An explanation must earn its place by surviving comparison, not by sounding compelling. This is where restraint becomes a discipline. Occam's principle demands that explanations remain as simple as the data allows before expanding outward. Extraordinary mechanisms are not forbidden, but they are not invited unless simpler ones fail completely. In a universe as large and varied as ours, unusual outcomes do not require unusual origins. Holding back interpretation does not weaken science. It preserves it. By resisting the urge to declare meaning too early, science protects itself from collapse later. The cost of patience is uncertainty. The cost of impatience is error. 3. Atlas offered a clear lesson in this responsibility. Faced with something unfamiliar and unrepeatable, the most rigorous response was not to explain more, but to explain less, to acknowledge what could be supported, and to leave the rest deliberately unresolved. In a world that rewards fast answers and confident narratives, does science still have the patience to defend uncertainty when uncertainty is the most honest position? 3. Atlas did not leave behind a message. It left behind data that can never be collected again. A fleeting record of light, motion, and interaction that exists only because the timing, geometry, and technology briefly aligned. Once it passed, the opportunity closed forever. The real value of that encounter was never about identifying exactly what the object was. It was about observing how science responds when clarity refuses to arrive. About whether the discipline prioritizes honesty over certainty when the evidence does not justify a conclusion. Science does not fail when it cannot produce a final answer. It succeeds when it resists the pressure to invent one. Saying we do not know is not a weakness. It is a boundary drawn deliberately. In defense of credibility and method, the limits of observation are not an embarrassment. They are information. They tell us where inference becomes fragile, where models begin to lean too heavily on assumption, and where restraint matters more than resolution. Recognizing those limits is part of understanding reality, not an admission of defeat. Future interstellar visitors will place us in similar positions. They will arrive without warning, remain briefly, and depart before certainty has time to form. We will always be reacting after the fact, measuring what escapes rather than what endures. The question, then, is not whether we will understand the next one better. It is whether we will be more disciplined in how we respond, whether we will protect uncertainty when uncertainty is justified, and resist the urge to replace it with confidence. 3. Atlas is gone, but it leaves behind a standard, not for discovery, but for humility. A reminder that the most honest outcome science can sometimes offer is a carefully defended unknown. If the universe does not require us to understand it, are we still willing to keep listening to the data, even when it refuses to tell us what we want to hear?